Tonight, we are going to visit the largest galaxy anyone has ever found. It sits more than 1 billion light years away in a quiet corner of the constellation Virgo, and it is so large that our entire galactic neighborhood, the Milky Way, Andromeda, and every small galaxy that drifts between them, could be swallowed inside it with room to spare. Its name is IC1101. You have probably never seen it. Almost no one has. Through even a large telescope, it is nothing more than a soft, pale smudge, a thumbprint of light pressed against the dark. But that smudge is a giant beyond easy imagining, a galaxy that may hold as many as 100 trillion stars. And here is the thing most people don't realize. The largest galaxy we have ever found is not in its prime. It is not growing brighter. It is not filling with young suns. It is old, and it is quiet. And by every measure astronomers know how to take, it is slowly dying. The biggest thing the universe ever showed us is already fading away. That is a strange thought and a peaceful one in its own enormous way. And by the end of tonight, you're going to understand exactly why. So let yourself settle in. Get comfortable, let your breathing slow down, and let the scale of this do what it does best. There is nothing here you need to remember, and nothing you need to do. Tonight is a long, slow drift towards something impossibly large and impossibly far away. And if you fall asleep somewhere along the way, that is exactly what this journey is for. Let's begin with the only question that matters at the start. How big is big? You live on a planet about 8,000 miles across. That number means something to you. You could, in principle, walk around the Earth in a few years of steady walking. Light, the fastest thing there is, crosses your entire planet in about a 23rd of a second. A beam of light could circle the world 7.5 times in the space of a single heartbeat. Hold that speed in your mind, because it is the ruler we will use all night. Light crosses the distance from the Earth to the Moon in a little over 1 second. It crosses the distance from the Earth to the Sun in about 8 minutes. It crosses the entire solar system, out past Neptune, past Pluto, past the far cold edges of the planetary realm in a matter of hours. And then it keeps going, out into the dark between the stars, and the numbers begin to stretch. 4 years and a few months of travel at that impossible speed, and light arrives at the very nearest star. Not the nearest interesting star. The nearest star, period. 4 years of flight for the fastest thing that can exist, just to reach the closest street lamp on our block. Now widen the view. Our Milky Way galaxy, the great slow wheel of stars we live inside, is roughly 100,000 light years across. 100,000 years for light to cross it. When a photon sets out from one rim of our galaxy, it begins a journey longer than the entire history of our species. And when it finally arrives at the far rim, everything about the world that launched it has changed beyond recognition. The Milky Way holds somewhere between 100 billion and 400 billion stars. We do not even know the count to within a factor of 4 because we live inside it, and you cannot easily count a forest while standing among the trees. By any human measure, the Milky Way is not just large, it is the largest thing most of us ever learn to picture at all. It is the final page of the scale most schoolbooks ever reach. And tonight, it is our unit of smallness. Because IC 1101, measured by the bright main body of its stars, is roughly 400,000 to 550,000 light-years across. 4 to 5.5 of our entire galaxies, laid rim to rim, just to span the part of it that shows up clearly in photographs. And that is only the beginning. Because, as we will see later tonight, this galaxy does not really end where the photographs end. Its outermost veil of stars fades outwards so gradually, so patiently, that astronomers have traced its faint glow out to roughly 2 million light-years from its center. Hold on to that number for a moment. 2 million light-years from the center, and still there are stars that belong to it. The distance from the Milky Way to the great Andromeda galaxy, the famous gulf that separates us from our nearest large neighbor, is about 2.5 million light-years. That gulf is one of the first truly humbling numbers anyone learns in astronomy. The nearest big galaxy is so far away that its light left before our species existed, and the faint outskirts of IC 1101 reach almost that entire distance out from its own heart. If you placed this one galaxy where the Milky Way sits tonight, its outer halo of stars would reach most of the way to Andromeda. Our galaxy, Andromeda, the Triangulum Galaxy, and dozens of small companion galaxies, the entire collection astronomers call the local group, could be set down inside its faint outer boundary like a handful of coins dropped into a lake. Think about that for a second. Every star you have ever seen with your own eyes belongs to the Milky Way. Every constellation, every bright planet-crossed night, every soft band of summer starlight, all of it is one galaxy, our galaxy. And there exists right now, out in the dark of Virgo, a single object that could hold our everything and Andromeda's everything and all the space between inside its own quiet sprawl of ancient suns. One object, one name in a catalogue. It is the kind of fact that does not frighten so much as it hushes. The universe builds on scales where our entire cosmic address becomes a detail. Numbers this large stop, meaning anything unless we slow them down. So let's slow them down. Imagine you could shrink the Milky Way, all 100,000 light-years of it, down to the size of a dinner plate. On that scale, the Andromeda galaxy is another dinner plate sitting about 25 feet away, across the room. The local group, our whole neighborhood, fits inside a modest house. On that same scale, IC 1101's bright central body is a disk somewhere between 4 and 5.5 feet across, a tabletop rather than a plate, and its faint outer halo, that 2 million light-year reach of scattered stars, spreads roughly 40 feet in every direction from its center, a glow the size of the entire house. One galaxy, the size of the house that holds our whole neighborhood. And on that dinner plate scale, the sun, our sun, with all its planets and moons and comets and every human being who has ever lived, is far too small to see at all. Not a crumb, not a speck of dust, smaller than a single atom of the plate. Here is another way to feel it. Light crosses our galaxy in 100,000 years. If a beam of light entered one side of IC 1101's bright body and flew straight through, the crossing would take it around 500,000 years. 500,000 years is roughly the entire span of time that anything resembling modern humans has existed on Earth. A photon could begin that crossing when the first true humans were learning to manage fire, and it would still be inside the same galaxy tonight, still flying, with the far edge not yet reached. And if that photon started instead at the very heart of the galaxy and flew outward through the faint halo, aiming for the last thin scattering of stars that still answers to this galaxy's gravity, the journey would take it around 2 million years. 2 million years inside one object, moving at the fastest speed the universe permits. There are single stars in that halo whose light crossing their own galaxy takes 20 times longer than the entire recorded history of humanity. And if light itself takes that long, think of what the crossing would mean for anything we could actually build. The fastest objects our species has ever launched into deep space are the Voyager probes, hurtling outward from the sun at around 38,000 miles per hour, a speed that would circle the Earth in under an hour. At that pace, a spacecraft needs roughly 17,000 years to cover a single light year. 17,000 years per light year against a galaxy 500,000 light years wide. Run the arithmetic gently, because it does not fit in the mind any other way. To cross just the bright body of IC 1101, a Voyager would need nearly 9 billion years, roughly 2/3 of the age of the universe itself. The sun will have died, swollen and faded to a cooling cinder before such a craft finished a single crossing. And to travel from the galaxy's center out to the far edge of its faint halo, the full 2 million light years would take around 35 billion years, 2.5 times longer than the universe has existed. There is no journey there. There is not even the dream of a journey. A galaxy like this is not a place one visits, it is a place one contemplates from a very great distance, which is exactly what we are doing tonight, and it is enough. And yet, for all that size, here is what you would actually see if you stood in a dark field tonight and looked toward the constellation Virgo, toward the exact patch of sky where this giant lives. Nothing. With your naked eye, nothing at all. The largest galaxy ever found is roughly 1,000,000 times too faint for human eyes. Even through a good amateur telescope, on a perfect night, far from city lights, you would see only the faintest grey breath of light, easy to mistake for a smear on the eyepiece. Size and distance cancel each other with almost perfect cruelty. The galaxy is titanic, and the gulf between us is more titanic still. That is the first great truth of tonight's journey. In this universe, even the largest thing ever found can hide in plain sight, dimmed into a whisper by nothing but distance. Which brings us to a June night more than 2 centuries ago, and a man standing in an English garden beside a telescope he had built with his own hands. The year was 1790. The date, June 19th. The man was William Herschel, a German-born musician who had moved to England to write and perform music, and who had, over the course of a remarkable second life, become the greatest telescope maker and the greatest observer of the night sky the world had yet produced. Herschel did not train as an astronomer. He came to the sky the way some people come to a second language, late, hungry, and with an outsider's disregard for what was supposed to be impossible. He taught himself to grind and polish telescope mirrors in his own home, casting metal discs and shaping them by hand hour after hour, sometimes so continuously that his sister Caroline fed him while he worked because he could not take his hands from the mirror. The telescopes he built were, quite simply, the finest on Earth. With one of them, 9 years before the night that concerns us, he had discovered the planet Uranus, the first new planet found since antiquity, and become the most famous astronomer alive. But Herschel's real obsession was not planets. It was the deep sky. Night after night, he swept his telescopes across the dark in slow, methodical strips, cataloguing everything that was not a star. Faint clouds, soft glows, little spirals and smudges and puffs of light that did not move like comets and did not resolve like star clusters. He called them nebulae, from the Latin word for mist, and he recorded thousands of them, far more than any human being before him. He had no way of knowing what most of them were. No one did. On that June night in 1790, sweeping through the stars of Virgo, Herschel's mirror caught one more of them. A dim, rounded glow, unremarkable in the eyepiece, one entry among many in a long night's work. He logged its position and moved on. He gave it no special attention because there was nothing in the eyepiece to suggest it deserved any. There was no way for him to know, none at all, that the faint mist he had just recorded was the largest single collection of stars any human eye had ever glimpsed, or that its light had been traveling toward his telescope since before complex life walked on land. Sit with that for a moment, because it is one of the gentlest ironies in the history of science. The largest galaxy ever found was discovered by a man who did not know what a galaxy was. He could not have known. In 1790, the word galaxy referred to one thing only, the Milky Way, the river of light across the summer sky, and even that was poorly understood. The idea that the universe contained other galaxies, other complete star systems as vast as our own, separated from us by oceans of empty space, would not be settled science for another 130 years. Herschel caught a leviathan in his net and recorded it as a minnow, and no one alive had the eyes to tell the difference. A century passed. Herschel's catalogues of nebulae grew and were expanded by his son John, and then gathered and reorganized by a Danish-born astronomer named John Louis Emil Dreyer into a great master list called the New General Catalogue, one of the most famous inventories in all of astronomy. Thousands of objects received the letters Ng, C, and a number. But observations kept coming, and so Dreyer compiled supplements, additional lists for objects found after the main catalogue closed. These supplements were called the Index Catalogues, and in the first of them, published in 1895, Herschel's faint smudge from that June night finally received the name it carries today: Index Catalogue Entry 1101, IC 1101. Not a name of honor, not a name of legend, a filing number in an appendix assigned by a cataloguer who, like Herschel, had no way of knowing what he was filing. The largest known object of its kind in the observable universe entered human records the way a misplaced receipt enters a shoebox. And there it sat, a number among thousands, while the world changed around it. Because to understand what IC 1101 actually is, humanity first had to answer a much bigger question. Perhaps the biggest question astronomy has ever asked and settled. Were the nebulae small clouds inside our Milky Way, or were some of them entire other Milky Ways unthinkably far away? This was not an idle question. It was the question of the size of the universe itself, and in 1920 it grew so sharp that two of America's leading astronomers held a formal public debate about it in Washington, an event remembered today simply as the Great Debate. One side argued the Milky Way was the universe and the spiral nebulae were minor clouds within it. The other side argued the spirals were island universes, separate galaxies in their own right, and that our Milky Way was just one of a countless multitude. The debate itself settled nothing. Debates rarely do. What settled it was a young astronomer named Edwin Hubble, working at the largest telescope of his day on Mount Wilson in California, who in the early 1920s found a special kind of pulsating star in the Andromeda Nebula, a star whose rhythm revealed its true brightness and therefore its true distance. The answer came back vast beyond argument. Andromeda was not inside the Milky Way. It lay far beyond the most generous boundary anyone had ever drawn for our own star system. A complete galaxy in its own right, an island universe after all. In a single measurement, the universe grew by a factor of thousands, and every faint smudge in Herschel's old catalogues became a candidate world of worlds. Almost overnight, the shoebox of receipts became a treasury. Astronomers began measuring distances to the catalogued nebulae, and the numbers kept coming back larger and larger. Millions of light years, tens of millions, hundreds of millions. The universe assembled itself before their instruments, galaxy by galaxy, and somewhere in that long accounting, the little entry numbered 1101 in the first index catalogue revealed its first secret. It was not nearby. It was not even moderately far. It lay around 1 billion light years away, deeper into space than almost anything Herschel had ever catalogued, which meant that the faint mist in his eyepiece on that June night had to be intrinsically enormous, luminous beyond any ordinary galaxy. just to be visible at all across such a gulf. The minnow was measured, and the measurement said Leviathan. Over the following decades, as telescopes grew and cameras replaced the human eye, the numbers around this object only became stranger. Its distance settled at a little over 1 billion light-years, with modern measurements placing it near 1.15 billion. Its light output proved to be immense, among the most luminous galaxies known anywhere. And its physical size, the actual span of the thing, produced figures that seemed to belong to a typographical error. Where ordinary large galaxies measured tens of thousands of light-years across, and giants measured perhaps a couple of 100,000, this object's soft glow just kept going, outward and outward, fading so gradually that the question stopped being, how big is it, and became unsettlingly, where does it end? That question, where does a galaxy end, turns out to be one of the deepest questions of tonight, and we will give it the time it deserves a little later. But first, we need to talk about the gulf itself, 1.15 billion light-years, because a number like that does not fit inside a human mind without help, and the help is worth the effort. The distance to this galaxy is not just a big number. It is a distance made of time, and the time it is made of contains almost the entire story of life on Earth. The light arriving at Earth from IC 1101 tonight has been traveling for roughly 1.15 billion years. Every photon that ever formed an image of this galaxy on a telescope's camera, every particle of light Herschel caught in his mirror on that June night, left home before there was a single leaf, a single fish, a single grain of coral on this planet. When that light began its journey, Earth was a water world of a very different kind. The continents existed, but they were bare rock and dust, brown and grey, and utterly lifeless, because life had not yet learned to survive on land. The only living things on the entire planet drifted in the seas, and almost all of them were single cells. The most sophisticated organisms on Earth, the crown of creation on the day that light departed, were mats of algae and colonies of microbes, quietly photosynthesizing in shallow, sunlit water. No eyes existed anywhere on our world. Nothing had ever seen anything. The light that shows us the largest galaxy in the known universe is older than sight itself, and that light has been falling continuously, patiently, the entire time. While that light crossed the void, Earth invented almost everything you know. Complex cells joined into the first true animals, soft and strange, pulsing in dark water. Then came shells and spines and the great explosion of forms that filled the ancient seas. Fish learned to swim. Some of them crawled onto the empty continents and stayed, and the bare rock slowly turned green. Insects rose into the air. Great forests grew and fell and turned to coal. The dinosaurs arrived, ruled for over 150 million years, an almost incomprehensible reign, and were erased in a single terrible afternoon when an asteroid found the Yucatan. Mammals crept out of the shadows and inherited everything. Apes stood upright on African plains. Ice ages came and went like slow breathing. And in the very last sliver of that immense span, a species learned fire, then farming, then writing, then telescopes. And one of its members, standing in a garden in England, tilted a mirror toward Virgo and finally caught the light that had been on its way for all of it. The entire story of complex life on Earth fits inside the travel time of the light you would see tonight, with room left over. When people say astronomy is a kind of time travel, this is what they mean, and it is not a metaphor. There is no now shared between us and this galaxy. There is only the long light, carrying an image of what was across a gulf that time itself needs 1 billion years to cross. And here is a gentle thought before we move on. It runs the other way too. If, somewhere in that enormous galaxy, on some planet circling one of its 100 trillion suns, something with eyes and instruments is looking back toward our little corner of the sky tonight. They are not seeing us. They are seeing our planet as it was more than 1 billion years ago, a blue and brown world wrapped in clouds, its continents empty, its seas full of nothing but drifting cells and quiet green film. They would find no cities, no lights, no radio whisper. They would file us away, perhaps in some catalogue of their own, as an unremarkable yellow star with an unremarkable damp planet, a minnow in their net. The symmetry is perfect and perfectly humbling. Across 1 billion light years, no one gets to see anyone as they really are, only as they were in the deep morning of their history. So that is the gulf. Now let us cross it and approach the giant itself, because up close, IC 1101 presents astronomers with a problem that sounds like a child's riddle and turns out to be one of the deepest questions in the science of galaxies. The problem is this: no one can say exactly where this galaxy ends. And in a very real sense, the famous claim you may have heard about IC 1101, the claim that made it an internet legend, the claim that it is 6 million light years across, is born from that riddle. Tonight, you are going to hear what the actual measurements say, because the true story is more interesting than the legend and no less vast. Start with what a galaxy's edge even means. A galaxy is not a solid object. It has no surface, no rim, no wall. It is a gravitational gathering of stars, gas, and unseen dark matter. And like a crowd leaving a stadium, it simply thins out with distance until, at some point that no one can quite put a finger on, you would say you are no longer in the crowd. For a galaxy like the Milky Way, with its bright, organized disk, the fading is relatively sharp, and the honest answer is still fuzzy. For a giant elliptical galaxy like IC 1101, a vast, structureless cloud of stars with no disk and no spiral arms, the fading is so gradual, so smooth, that the choice of where to draw the boundary changes the answer not by a little, but by a factor of 10. So astronomers use standard rulers. One of the most common is called The half-light radius, the radius of the circle that contains half of all the light the galaxy emits. It is a way of asking, where is the meat of this thing, ignoring the thin outer mist? For the Milky Way, that kind of measure gives a figure of a bit over 10,000 light-years. For IC 1101, the half-light radius is roughly 212,000 light-years. Read that again, slowly. The circle containing just half of this galaxy's light is, by itself, wider than 4 Milky Ways side by side. The inner half, the core region, the part astronomers would call the central concentration, our entire galaxy, is a rounding error on this object's downtown. Then there is the more generous standard measure, the one used for the figures you heard earlier tonight, which traces the galaxy's light out to a chosen threshold of faintness, the level where the glow becomes too dim to reliably map. By that measure, the main body of IC 1101 spans roughly 400,000 to 550,000 light-years, depending on the exact threshold chosen. That is the defensible, published, peer-reviewed size of the galaxy proper, 4 to 5.5 Milky Ways across, enormous beyond any rival in its class, and yet, you will notice, not 6 million light-years. So where did the legend come from? It came from something real, and here the story deepens rather than deflates. In 1990, a team of astronomers, Juan Usson, Stephen Bogue and Jeffrey Coeur, pointed sensitive instruments at this galaxy and did something painstaking. Instead of photographing the bright body, they measured the almost invisible outskirts, the diffuse veil of scattered starlight that extends beyond any normal boundary. Light so faint it is thousands of times dimmer than the natural glow of Earth's own night sky. And they found that it just kept going. The veil of stars followed a smooth mathematical curve outward to roughly 2 million light-years from the galaxy's center. And even there it had not so much ended as dissolved beyond the instrument's reach. Trace that veil across the full width from one far side to the other, and you have a single connected envelope of starlight roughly 4 million light-years wide, which eager retellings over the years have rounded and stretched into the famous 6. The number grew in the telling, as numbers do, but the discovery underneath it is genuine. And it is stranger than the legend because it raises the question the legend skips right over. If there are stars flowing smoothly out to 2 million light-years from the center, do they belong to the galaxy at all? Or do they belong to something bigger? Because here is the secret that reframes everything you have heard so far, the key that unlocks the whole night. IC 1101 does not live alone. It sits at the exact center of one of the mightiest structures in the nearby universe, a great swarm of galaxies called Abell 2029. And you cannot understand the giant without understanding the swarm. Galaxies, it turns out, are social creatures. They gather in groups and clusters bound to one another by gravity, orbiting a common center like bees around an unseen hive. Our Milky Way belongs to a small, quiet gathering, the local group, A few dozen galaxies drifting together through space, of which only ours and Andromeda are truly large. But scattered through the universe there are gatherings of an entirely different order, rich clusters containing hundreds of bright galaxies and likely thousands of fainter ones, all packed into a region only a few tens of millions of light years across, all swarming in each other's company, all falling endlessly around a shared center of mass. Abell 2029 is one of these, and it is a magnificent specimen, a swarm spanning millions of light years, bright with galaxies, the way a city is bright with windows. The cluster takes its name from the astronomer George Abell, who in the 1950s combed photographic plates of the entire northern sky and catalogued thousands of these galaxy swarms, and whose numbering system, like Dreyer's before him, turned wonders into filing entries. Entry 2029 happens to contain a king. And the deep fact about rich clusters, the fact that explains our giant, is this. A cluster is not just a crowd of galaxies, it is an arena. The galaxies within it are not fixed in place. They fall and swing and pass one another, century after century, eon after eon, and their gravity works on each other constantly, tugging, distorting, stripping. A cluster is an environment where galaxies collide, merge, are torn apart, and are consumed. And it has been running that brutal, beautiful experiment for billions of years. At the very bottom of the cluster's gravitational valley, at the still point around which all those hundreds of galaxies swarm, there is a throne. Whatever sits on that throne receives everything that falls to the bottom. Every galaxy that loses too much speed, every stream of stars torn loose in a close encounter, every drift of gas stripped from a passing spiral, all of it, given enough time, spirals down to the center and is absorbed by whatever waits there. Astronomers have a name for the galaxies that occupy such thrones. They call them brightest cluster galaxies, and they are, as a class, the largest galaxies in the universe. Nothing else comes close, and by the end of the next part of our journey, you will understand exactly why they, and only they, can grow so monstrous. C1101 is the brightest cluster galaxy of Abell 2029. It sits precisely at the center of the swarm, precisely at the bottom of the valley. And it has been sitting there, receiving, for most of the age of the universe. Seen in that light, the riddle of its edge becomes almost poignant. Those stars 2 million light-years from its center, the veil that made it a legend, they occupy the borderland between belonging to the galaxy and belonging to the cluster. Astronomers even have a name for the light of stars that belong to no galaxy at all anymore. Stars stripped loose in the endless gravitational commerce of the swarm, orphaned suns that drift through the cluster's spaces, owing allegiance only to the cluster itself. They call it intra-cluster light, the glow-between. Around IC 1101, the galaxy's own outskirts and the cluster's orphaned starlight blend into each other with no seam, no boundary, no place where anyone can honestly say the galaxy stops and the graveyard of consumed galaxies begins. And perhaps that is the truest possible description of this object. It is not a galaxy with an unusually large halo. It is the place where a whole cluster's history of consumption pools and glows, a fire fed for 10 billion years, still warm at the center of the swarm. Which raises the question we have been circling all night, the question of how. How does the universe actually build such a thing? What does it look like over billions of years for one galaxy to eat hundreds of others? That is where our journey goes next, into the slow violence at the heart of the swarm and into one of the most quietly dramatic processes in all of nature. A process astronomers call, without any embarrassment at all, galactic cannibalism. To understand how a galaxy eats another galaxy, the first thing to let go of is the image of a collision. When two galaxies meet, almost nothing actually hits anything. Stars are so small compared to the spaces between them that two entire galaxies can pass directly through one another, with essentially no star ever striking another star. If the Sun were a grain of sand in Europe, the nearest star would be another grain of sand thousands of miles away. Galaxies are not walls meeting walls, they are mists meeting mists, and mists pass through each other. What collides is not matter, but gravity. As the two star swarms interpenetrate, each star feels the shifting pull of the whole other swarm. Orbits are bent, streams of stars are flung outward into enormous arcs, and the two systems, if they are moving slowly enough, lose the energy they would need to escape each other. They fall back. They pass through again. They fall back again. Over hundreds of millions of years, the passes become shorter and deeper. The structures of both galaxies dissolve into a single churning cloud, and eventually there is only one galaxy where there had been two, rounder, larger, and more disordered than either parent. Astronomers see every stage of this process frozen in snapshots across the sky. Galaxies approaching, galaxies entangled, galaxies with double cores still settling into one. The universe is full of mergers, the way a forest is full of fallen trees, evidence of a process too slow to watch but too common to miss. Now place that process inside a rich cluster and aim it at the galaxy on the throne. A brightest cluster galaxy at the bottom of the gravitational valley enjoys a terrible advantage. It does not need to chase its meals. The cluster delivers them. Any galaxy orbiting within the swarm plows continuously through the cluster's spaces, and as it does, something subtle and relentless happens to it, a process called dynamical friction. As the smaller galaxy moves, its gravity gathers a faint wake of stars and dark matter behind it, the way a boat gathers a wake in water, and that wake, trailing always behind, pulls always backward. The galaxy slows, not quickly. A wake of starlight is a gentle break, but the cluster has billions of years and the break never releases. Orbit by orbit, the smaller galaxy loses speed, and losing speed, it sinks, spiraling slowly down the valley toward the center, toward the waiting giant. The process is as inevitable as sediment settling in still water. Given time, and the universe has given this cluster nearly all the time there has ever been, the center collects everything that sinks. And at the center of Abel 2029, everything that ever sank arrived, eventually, at the same address. This is what the word cannibalism means in the science of galaxies, and it is worth being precise, because the truth is slower and stranger than the word suggests. The giant does not lunge, it waits. A doomed galaxy's final approach can itself take 1 billion years, its outer stars stripped away first, pulled into long tidal streams that wrap around the giant like ribbons, its dense core holding together longest, plunging deeper with each pass, until at last even the core dissolves and its stars simply become part of the giant swarm, indistinguishable, absorbed, their old citizenship erased. Nothing burns, nothing explodes. A galaxy that shone for 10 billion years, that may have had its own spiral arms, its own star nurseries, its own planets and moons, and for all anyone can say, its own quiet watchers, is smoothed into the anonymous body of the giant so gradually that there is no moment anyone could point to and say, now it is gone. The stars themselves barely notice. Their planets keep their orbits. If there was ever a world in one of those consumed galaxies with beings looking up at night, the merger would not have been a catastrophe in their sky, only a slow rearrangement of it, playing out over more generations than their species would likely last. Whole galactic histories end this way at the bottom of clusters, not with destruction, but with digestion so gentle it cannot be distinguished from peace. How many times has this happened at the center of Abel 2029? No one can give an exact count, because the evidence of each meal is precisely what gets erased. But the arithmetic of the giant's body gives an unmistakable answer. Many, perhaps hundreds. IC 1101 holds by massive stars on the order of 100 or more Milky Ways worth of material gathered into one system. No galaxy is born that large. Galaxies form from collapsing clouds in the early universe at sizes far more modest, and everything beyond that must be acquired, merger by merger, sinking meal by sinking meal, over 10 billion years and more. When you look at a deep photograph of this galaxy, that is what you are actually seeing, not a thing, but a history, a ledger of everything that ever fell to the bottom of one of the great gravitational valleys of the nearby universe, written in starlight, still glowing. Some of those stars formed in the giant itself in its own youth, when it too made stars, but a vast share of them, likely most of the stars in its outer body and halo, were born elsewhere, in other galaxies, under other skies, and were collected the way a river delta collects soil from 1,000 miles of countryside. The veil of stars stretching 2 million light-years from its center is not a coat the giant grew. It is a memory of everything it has eaten, worn on the outside, fading into the orphaned starlight of the cluster, because that is, in truth, what it is made of. And the record of consumption is written somewhere else too, somewhere far stranger than the halo. It is written in the very center of the giant, in the innermost few thousand light years, where astronomers found something that should not be there. Or rather, where they found nothing, in a place where there should have been something. In 2017, a team of astronomers led by Billy and Dullo made a careful study of the light profile of IC 1101, mapping how the galaxy's brightness rises as you approach its core. In a normal giant elliptical, the starlight climbs smoothly toward the center, denser and denser, brighter and brighter. A mountain of stars rising to a peak. In IC 1101, the climb simply stops. Across the innermost region of the galaxy, a span of roughly 14,000 light years, the density of stars flattens out into a plateau, as if the peak of the mountain had been sliced off and carried away. Astronomers call such a structure a depleted core, and small versions of them are well known in giant galaxies. But nothing like this. The scoured region at the heart of IC 1101 is the largest depleted core ever measured in any galaxy. An emptiness wide enough to hold 10 side-by-side copies of the Milky Way's central bulge, sitting exactly where the galaxy should be most crowded. Careful modeling of the missing light suggests that something on the order of 500 billion suns worth of stars are simply not there. Stars the galaxy's own structure says it should contain. Gone from the middle of the richest star system ever found, 500 billion suns, missing from the vault, and the vault door still locked. Something removed them, and astronomers are confident they know what it was. At the center of nearly every large galaxy lies a supermassive black hole. Our own Milky Way keeps one, a body of about 4 million times the Sun's mass, quiet and patient behind the star clouds of Sagittarius. Andromeda holds one perhaps 30 times heavier. And as a rule, written across every galaxy astronomers have ever weighed, the bigger the galaxy, the bigger its central black hole. The two grown together across cosmic time like a pearl and its shell. Now remember what IC 1101 is, a galaxy assembled from hundreds of others. Every substantial galaxy it ever consumed brought a dowry, its own central black hole, delivered down the same slope of dynamical friction, sinking through the giant's body toward the center, where the reigning black hole waited. And when two supermassive black holes approach one another at the heart of a galaxy, they perform one of the most violent dances in all of physics. They pair into a binary, two unthinkable masses circling one another, and that circling pair becomes an engine of expulsion. Any star that strays close to the whirling pair is caught in a gravitational slingshot and hurled away at enormous speed, flung clean out of the galactic center, sometimes clean out of the galaxy. Each ejected star carries away a sliver of the binary's orbital energy, so with every star it throws, the pair tightens and whirls faster and throws harder. Over millions of years, a tightening black hole binary excavates the heart of its host galaxy, scattering the densest, most crowded stellar neighborhood in the system to the winds. before the two holes finally spiral together and merge into one, sending gravitational waves rolling across the universe like a struck bell. This, the evidence says, is what happened at the center of IC 1101. Not once, again and again and again, one round for every major galaxy it ever swallowed, each merger delivering a new black hole, each new black hole scouring the core afresh on its long spiral to union with the reigning monster. The 14,000 light-year emptiness at the heart of the giant is the accumulated footprint of that repeated dance, the scar of every marriage of monsters the galaxy has ever hosted. The missing half-trillion suns were not destroyed. They were exiled, thrown into the far body and halo of the galaxy, a diaspora of evicted stars still out there tonight, still carrying the momentum of their expulsion. And here is something quietly wonderful about those marriages of monsters. We may have already heard them, not from IC 1101 specifically, but from its kind, from the whole population of paired supermassive black holes spiraling toward union in giant galaxies across the universe. Every such pair, in its final ages of circling, rings the fabric of space itself, sending out gravitational waves, ripples in the very geometry of distance, slow and vast, with wavelengths measured in light years. No instrument on Earth is large enough to catch waves like that. So astronomers built an instrument out of the galaxy itself. Scattered through the Milky Way are pulsars, the spinning collapsed cores of dead stars, some of them rotating hundreds of times per second with a regularity that rivals atomic clocks, each one sweeping a lighthouse beam of radio waves across the Earth. If a gravitational wave rolls through the space between us and a pulsar, the distance changes by a whisper, and the ticking arrives a fraction early or a fraction late. Watch enough pulsars for enough years with enough patience, and the whole sky becomes a detector thousands of light years wide. Teams of astronomers did exactly that, monitoring arrays of pulsars for decades, and in 2023, they announced the reward. The timing of the pulsars is not perfectly steady. It carries a faint, correlated murmur, exactly the pattern expected if the universe is filled with a low background hum of gravitational waves, the combined slow chorus of countless supermassive black hole pairs, all circling, all tightening, all singing at once across cosmic time. The chief suspects for that chorus are precisely the unions we have been describing, the mergers that build and scour the hearts of the greatest galaxies. Somewhere in that hum, blended beyond any hope of separation, may be the long note of the next marriage preparing at the bottom of some distant valley. The dance that hollowed the giant's heart is not ancient history. It is the standing music of the universe playing underneath everything too deep for any ear but a galaxy's worth of clocks. And the monster itself, the final product of all those unions, the black hole that sits at the exact center of the largest galaxy ever found. How large is it? Here astronomers must reason indirectly because at over 1 billion light-years, even IC 1101's core is too distant for the direct measurements used on nearby galaxies, but the size of the scoured core is itself a scale, because a bigger binary excavates a bigger emptiness, and the emptiness here is the biggest ever seen. Working from that, and from the relations that tie black holes to their host galaxies everywhere else in the universe, the estimates land in a realm that has few rivals anywhere in astronomy, somewhere between roughly 40 billion and 100 billion times the mass of the Sun. Pause on the low end of that range. 40 billion suns gathered into a single point of collapsed matter. That is roughly 10,000 times the mass of the Milky Way's central black hole. A black hole of that mass has an event horizon, a boundary of no return, wider than our entire solar system, wider than the orbit of every planet, so large that light itself would need days to cross it. If the upper estimates are right, the black hole at the heart of IC 1101 is among the very largest single objects known to exist, a candidate for the heaviest black hole ever found, sitting in the deepest gravitational valley of the nearby universe, wearing a galaxy of 100 trillion stars the way a stone wears moss. It does not rage. It barely feeds anymore. It simply sits at the still point of the swarm, the final inheritor of every center of every galaxy that ever sank into the valley. Everything about the giant, its size, its halo, its hollowed heart, and its silence, leads back, in the end, to gravity, given enough time. Silence. That is the word that carries us into the next part of the journey, because for all its mass and all its history, the single most defining fact about IC 1101 tonight, the fact promised at the very beginning, is what it no longer does. It no longer makes stars. The largest galaxy ever found, keeper of 100 trillion suns, has essentially stopped creating new ones, and has been stopped for a very, very long time. Astronomers have a phrase for galaxies in this condition, and it is one of the bleakest and most beautiful phrases in the whole science. They call them red and dead. To understand what that means, and why it happened, and why it is nevertheless not quite the ending it sounds like, we need to talk about the lives of stars themselves and about the color of time. Stars are born from cold. That is the first thing to understand, and almost the only thing, because nearly everything else about the life and death of galaxies follows from it. A star begins as a cloud of gas, mostly hydrogen, drifting in the space between the stars of its galaxy. For that cloud to collapse into a star, gravity must win a contest against pressure, and pressure comes from heat. A warm cloud puffs itself up and refuses to fall together. Only when gas grows cold enough, cold almost beyond imagining, a few degrees above absolute zero, can it grow quiet enough to collapse, fragment, and ignite into new suns. So, the recipe for a star-making galaxy is simple. Keep a deep reserve of gas and keep it cold. Our Milky Way does this beautifully. Its spiral arms are wrapped in lanes of cold, dark clouds. And from those lanes it kindles new stars steadily, a few suns worth of new starlight every year. as it has for billions of years. When you see a photograph of any spiral galaxy glowing blue along its arms, that blue is the signature of youth. The hottest, brightest, most massive stars burn blue-white, and they live so briefly, mere millions of years, that their presence anywhere means stars were born there practically yesterday. Blue is the color of now. A galaxy with blue regions is a galaxy with a working nursery. Now look at IC 1101, and the photographs tell you the story before any measurement is made. There is no blue anywhere, no arms, no lanes of dark dust, no knots of bright young clusters. Just a single smooth gradient of pale gold light from the crowded center to the fading halo, the unmistakable complexion of a galaxy whose stars are old. All those short-lived blue suns burned out long ago, ages ago, and were never replaced. What remains is everything that lasts, the slow, steady, middleweight stars like our sun, and smaller yellowing and reddening as the whole population ages together. Astronomers looking closely at giants like this find the light of stars that formed roughly 10 billion years ago, when the universe itself was young and clusters like Hubble 2029 were first assembling. This galaxy had its age of creation, and it was magnificent. In those early eons, it must have blazed with starbirth on a scale our galaxy never approached. Hundreds, perhaps thousands of new suns worth of stars per year, lighting up the young cluster like a furnace. The universe has few sights, even in imagination, to rival a brightest cluster galaxy in its era of formation. But that era ended billions of years before the Earth was formed. The furnace went out, and it has stayed out ever since. Red and dead, the astronomers say. Red because the surviving stars have aged into gold and crimson. Dead, not because anything perished, but because nothing new is being born. It is the deadness of a still nursery, not a battlefield, a library after closing time. Everything precious is still on the shelves, only the acquisitions have stopped. But why? That is the real question, and it is sharper than it looks, because the galaxy is not out of raw material. This is one of the great puzzles the giant helps astronomers study, and the answer they have assembled is wonderfully strange. Hubble 2029, like all rich clusters, is filled with gas, an enormous atmosphere of it, spread through the whole cluster and pooling most densely right where the giant sits, at the bottom of the valley. There is more mass in that cluster gas than in all the stars of all the cluster's galaxies combined, a reservoir that could, in principle, build trillions of new suns. The problem is its temperature. The same gravitational valley that made the giant also heats the atmosphere it sits in. Gas falling into the cluster's enormous gravity crashes inward at tremendous speed, and all that energy of falling becomes heat, raising the cluster's atmosphere to tens of millions of degrees, so hot that it shines not in visible light, but in X-rays. A vast, invisible glow wrapped around the swarm. Space telescopes see rich clusters like Hubble 2029 as blazing clouds of X-ray light, an ocean of fire with galaxies drifting inside it, like ash. And gas at millions of degrees cannot make stars. It is the exact opposite of the cold, quiet a nursery needs. The giant is, in the cruelest sense, a creature dying of thirst in the middle of an ocean, surrounded by more star-making material than any galaxy in the nearby universe, and unable to drink a drop of it because every drop is fire. And yet, hot things cool. Given a few billion years, the densest gas at the cluster's center should radiate away its heat, settle, condense, and rain down onto the central galaxy as star fuel. Astronomers once expected exactly this, torrents of cooling gas cascading onto brightest cluster galaxies, igniting them with new star formation. When they looked, the torrents were not there. Cluster after cluster, the gas hangs at the edge of cooling, and something keeps stopping it, reheating the center over and over, on exactly the schedule needed to keep the nursery closed. That something, the evidence now says, is the black hole. The same monster that scoured the galaxy's core also guards its barrenness. Even a modest trickle of cooling gas sinking to the exact center of the galaxy falls eventually into the grip of the central black hole, and a feeding black hole is the most efficient engine in the universe. As matter spirals in, the black hole flings a portion of it back out in colossal jets, beams of energized particles that punch outward through the galaxy and into the cluster's atmosphere, inflating enormous rising bubbles of heat, stirring the ocean and warming the very gas that was trying to cool. The flow chokes off. The black hole, no longer fed, quiets down. The gas begins to cool again, trickles inward again, wakes the black hole again. A thermostat, planet-sized in its components, galaxy cluster-sized in its reach, cycling patiently on timescales of millions of years, holding the largest galaxy ever found at a permanent simmer just above the temperature of rebirth. The heart that the mergers built now keeps the whole body from ever flowering again. There is something almost mythic in the economy of it. The engine of the galaxy's growth became the warden of its stillness, and the two facts are not separate facts. They are one fact. Greatness on this scale seals its own nurseries. Every brightest cluster galaxy astronomers survey tells some version of the same story, and IC 1101 tells it at the top of its voice, which is, of course, a whisper. So the giant will make no new light. What it has is what it will keep, and what it has is still beyond counting. And this is where the phrase red and dead quietly fails as a description, because the death of a galaxy on the inside would not feel like death at all. Let us actually go there. Let this be the part of the journey where we stop measuring and simply stand inside the thing, because the view from within a dying giant is one of the calmest skies the universe knows how to make. Imagine a planet then, somewhere in the middle body of IC 1101, circling one of its 100 trillion suns, an old orange star, steadier and longer lived than our own. There have been hundreds of billions of chances for such a planet to exist, around stars that have had 10 billion years of quiet in which to keep their worlds safe. So this is not an idle dream. It is close to a statistical certainty that such worlds are there. And consider what kind of worlds they would be. The stars of the giant are on the order of 10 billion years old, which means their planets are two worlds twice the age of the Earth, worlds that were already ancient, already settled into their long middle age, before our sun had even formed from its cloud. Whatever geology they began with has long since run its course. Whatever oceans they hold have held their shores for eons beyond counting. Time on such a world would be a different substance than it is here, deep, still, and untroubled, like water at the bottom of a well. If life ever kindled on any of them, it has had a head start on us of 5 billion years, and if it never did, then those worlds have simply been keeping their quiet the whole time, sunrise after sunrise, 10 billion years of unwitnessed evenings, patient as furniture in a locked house. Either way, the giant is almost certainly the largest single collection of quiet places in the known universe, trillions of shores and plains and slow weather systems, all of them old beyond imagining, all of them wrapped in the same unhurried light. Pick one of them now, whichever one your drifting mind prefers. Stand on it at nightfall and look up. The first thing you would notice is that the night is not black. It is deep charcoal, washed with a faint pearly sheen from horizon to horizon, because you are inside a cloud of 100 trillion suns, and their combined glow surrounds you the way city glow surrounds a town dweller. The second thing you would notice is the stars themselves and how strange their arrangement would seem to eyes raised on Earth. There is no Milky Way, no bright band across the sky, because a band is the signature of living inside a flat disk. And this galaxy has no disk. Its stars fill a vast, rounded swarm, the same in every direction, so the stars would be spread evenly across the whole sky. No galactic north, no preferred plane, just an even, gentle salting of light everywhere you look. And the colors. Almost every star in that sky would burn gold or amber or deep red. No young blue beacons, no violet-white giants of the kind that stud Earth's sky in Orion. The nurseries closed 10 billion years ago, and every star above you would be a survivor, an elder, part of the longest-lived generation the universe produces. A sky of embers, not one of them flickering, not one of them new, every single one of them older than your world, however old your world might be. Nights would pass in absolute serenity, and so would eons. No nearby nursery means no nearby giant stars, and no nearby giant stars means, for the most part, no supernovae, none of the titanic explosions that periodically light up and endanger the neighborhoods of younger galaxies. The great violence of the galaxy's youth is finished. Its stars are precisely the kind that do not explode, burning their fuel with the slow discipline that makes 10 billion more years an entirely reasonable expectation. If you wanted to design the safest, stillest, most patient sky in the universe, the sky least likely to change in any way on any night for the next 1,000 generations of watchers, you would design the sky of a red and dead giant. Dying, it turns out, looks like peace. The most enormous thing the universe ever made has settled into the longest bedtime the universe knows how to arrange, and its 100 trillion suns are the nightlights. Hold that ember sky in your mind, because it changes the meaning of everything we measured earlier tonight. From outside, through our telescopes, IC1101 is a pale smudge, a filing number, a curiosity of scale. From inside, it is trillions of quiet evenings happening at once, under skies that have not meaningfully changed since before the Earth existed. Both of those are true at the same time, and the distance between those two truths, between the smudge and the skies, is the real size of the thing, the size no ruler measures. And yet, patient as it is, that stillness is not eternal. The embers have a schedule, the giant has a future, and so does the swarm around it, and so, for that matter, do we, because the story of what happens next to IC 1101 turns out to be, with the details changed and the clock run forward, the story of what happens to every galaxy, including the one you are lying inside tonight. But before we read those last chapters, honesty asks us to pause on a fair question. All night we have been calling this the largest galaxy ever found. How do astronomers actually know that? Who are the rivals? And what does largest even mean in a universe that refuses to draw hard edges around anything? The answers take us on a short tour of the record books, and every stop on the tour is a wonder in its own right. Start with how you even measure a galaxy at 1 billion light years, because the honest answer is, with enormous care, and in several completely different ways at once, and the ways do not always agree. The first way is simply light. Astronomers take long, deep exposures and map how the galaxy's brightness falls off from the center outward, drawing contour lines of glow the way a surveyor draws contour lines of elevation. That map gives the sizes we have used all night, the half-light radius, the threshold boundaries, the faint outer veil. It is painstaking work because the outskirts of a giant elliptical are dimmer than the natural air glow of Earth's own atmosphere, dimmer than the scattered light inside the telescope itself, and a single careless subtraction can invent or erase 100,000 light-years of galaxy. Whole careers have been spent arguing about the outer contours of bright galaxies, and the arguments are not pedantry. They are the actual substance of the question, where does a galaxy end? The second way is motion. Stars in a galaxy move and their speeds betray the mass that holds them, all of it, shining or dark. Astronomers cannot follow a single star at this distance, but they can read the combined starlight and measure how its spectral lines are smeared by the swarming motion of billions of stars along every line of sight. Faster swarming meaning deeper gravity, meaning more mass. The stars of I C1101 swarm fast, and the answer comes back in the trillions upon trillions of solar masses, climbing steeply the farther out you measure, long before the cluster's full dark reservoir is even counted. And the third way is the hot atmosphere itself. The X-ray glow of the cluster's gas traces the shape and depth of the gravitational valley, the way mist traces the shape of a real valley at dawn. And the Valley of Abel 2029 is among the deepest and smoothest ever mapped. 3 independent instruments, 3 different kinds of physics, light, motion, and heat, all pointing at the same conclusion. Whatever boundary you choose to draw, the thing at the center of this cluster is the most enormous single stellar system in any catalogue on Earth. But every heavyweight champion has challengers, and the challengers are glorious. Consider first the strange case of Malan 1. In 1986, an astronomer named David Malin, a master of photographic technique, was amplifying deep images in search of faint galaxies when he uncovered something no one expected: a spiral galaxy, like ours in form, but built at a scale no spiral was thought able to survive, and shining so feebly per patch of sky that it had hidden in plain sight for decades. Malan 1's disk, as later measurements showed, spans on the order of 650,000 light-years, several times the span of the Milky Way, with spiral arms so vast and so dilute that a single arm segment could contain our whole galaxy's disk. It remains the largest spiral galaxy known, a kind of ghost cathedral, and it proves that gigantism is not the private property of ellipticals. Yet even Malan 1, laid beside tonight's giant, reaches only partway across the bright body, and nowhere near the veil. The champion's spiral is a province, not an empire. Then there are the radio giants, and here the word largest gets genuinely slippery in a way worth savoring. In 2022, astronomers combing survey data announced a galaxy nicknamed Alcyoneus, after a giant of Greek myth, an otherwise ordinary-looking elliptical that has blown 2 immense plumes of radio-bright plasma from its central black hole, jets inflated over eons into lobes that span, tip to tip, roughly 16 million light-years. 16 million. Measured lobe to lobe, that structure dwarfs everything else in tonight's story. And Alcyoneus is sometimes called the largest galaxy known for exactly that reason. But look closely, and the crown dissolves. The lobes are not stars, they are thin, exhaled plasma, a breath, a smoke ring blown into the void by a black hole's jets, containing less matter than a small galaxy despite their span. The stellar body of Alcyoneus, the actual gathering of suns, is smaller than the Milky Way's neighborhood giants, a fraction of IC1101's bright body alone. Whether it is the largest galaxy depends entirely on whether you measure the singer or the note the singer is holding. For a gathering of stars, a body, a place where worlds can exist, the record still lives at the center of Abel 2029. And there are the deep field monsters, the brightest cluster galaxies of clusters even richer and more distant than Abel 2029, and among them, real rivals breathe. The central galaxy of the Phoenix cluster, nearly 6 billion light-years away, is a titan of comparable mass with a black hole that may rival or exceed our giants, and it does something almost scandalous for its class. It still forms stars hundreds of suns worth per year because its cluster's thermostat, for reasons astronomers are still working out, is failing to fully choke the cooling flow. There are quasar-host galaxies whose central black holes are measured in the tens of billions of suns. There are surely, in the unsurveyed distances, in the thousands of clusters no one has yet examined deeply, other systems in the same weight class, and it would be foolish to promise that no bigger body will ever be found. Astronomers do not promise that. What they observe is this. After more than a century of ever deeper surveys across the entire visible sky, nothing yet measured has displaced the giant of Abel 2029 from the top of the list of stellar bodies, and everything in the physics of structure, everything we walked through tonight, says that whatever rivals exist must be its siblings, other brightest cluster galaxies in other deep valleys, built by the same patient recipe, crowding the same ceiling. The record may someday change hands, the kind of object holding it will not. The universe has exactly one way of making its largest galaxies, and it has already shown us the way. And the way is the throne at the bottom of the valley, and the waiting, and the meals. There is something quietly satisfying in that, something that turns the record book from trivia into physics. The tallest mountains on Earth are not scattered randomly. They stand where continental plates collide because that is the only process that can raise them. The largest galaxies are the same. They stand at the centers of the richest clusters, one per throne, because that is the only place the universe can raise them. Find a deep enough valley, and you will find a giant at the bottom of it. Astronomers now use brightest cluster galaxies as markers for exactly this purpose, lighthouses for locating the great concentrations of mass in the universe. Wherever the survey telescopes find one of these overwhelming central galaxies, they have found the top of another ladder of hierarchical growth, another one in 100,000 whisper from the primordial fog, amplified for 13 billion years. IC 1101 is simply the nearest, truly extreme example, close enough at its mere billion light-years to be mapped in the detail that made tonight possible. It is not a freak, it is a law of nature, wearing its crown in public. So the title holds with all the honest asterisks attached, and now the fair question has a fair answer. Largest gathering of stars ever measured, championed by the ruler of light, championed by the ruler of motion, championed by the ruler of heat, rivaled only by its own kind, and displaced by nothing in over 2 centuries of looking, which clears the way, at last, for the claim we have saved, the strange words at the very top of tonight's journey, the idea that the record holder itself should not, by any reasonable accounting, exist at all. The title of tonight's journey made a claim, and it is time to make good on it. The largest galaxy ever found, the title said, should not exist. Astronomers do not mean by this that the galaxy breaks the laws of physics. It obeys them perfectly, as everything does. What they mean is something more interesting. Objects like IC 1101 sit at the extreme outer edge of what the universe's own history permits, so far out along the curve of possibility that each one is a kind of miracle of circumstance, requiring almost every advantage the cosmos can grant, granted all at once, and sustained for nearly all of time. To see why, you have to understand how structure grows in our universe and why that growth has a ceiling. This is the deepest water we will swim in tonight, and it is worth every slow stroke, because at the bottom of it lies one of the most quietly astonishing facts in modern cosmology. The universe is nearly finished building things. Begin at the beginning, nearly 14 billion years ago. The infant universe was almost perfectly smooth, a hot fog of matter spread with an evenness that still startles the scientists who measure its afterglow. Almost perfectly smooth, but not quite, and everything hangs on that not quite. Sprinkled through the fog were tiny irregularities, regions a whisper denser than average, differences of merely 1 part in 100,000, the faintest possible fingerprints on an otherwise flawless surface. Gravity did the rest. A region slightly denser than its surroundings pulls a little harder, gathers a little more, becomes denser still, and pulls harder still. Given time, gravity is the great amplifier of tiny advantages, an amplifier with infinite patience. The whisper-dense spots gathered gas and dark matter, collapsed and lit up as the first small galaxies. Small ones first, that is the crucial pattern, because small irregularities collapse fastest. Then the small galaxies, clustered near one another in the larger density swells, began to merge into bigger galaxies, and the bigger galaxies gathered into groups, and the groups drained together into clusters, structure assembling itself upward, rung by rung, small into large, into enormous, a process astronomers call hierarchical growth. Everything vast in tonight's story, the giant, the swarm, the valley, is the top of that ladder, the final amplification of a 1 in 100,000 whisper in the primordial fog. If you want a single sentence for where IC 1101 came from, it is this. It grew from what was probably one of the very densest whispers in this entire region of the universe, a spot so favored that it collapsed early, fed hugely, drew a whole cluster into being around itself, and then spent 13 billion years at the bottom of the valley collecting everything the valley funneled down. First, and biggest advantage, compounding without interruption for the entire age of the cosmos. That is the recipe, and it explains something that might otherwise puzzle you. Why is the largest galaxy not in some exotic distant corner of the early universe? Why is it here, in the relatively recent, relatively nearby cosmos? Because size like this is not a birth condition. It is an accumulation, and accumulation takes all the time there is. The universe could not have built IC 1101 any faster, because the universe needed those 13 billion years to deliver the meals. Now for the ceiling and the reason the recipe can barely be repeated. All the while gravity has been building upward, the universe itself has been expanding, space stretching, distances between regions growing, and the expansion works against the building. Gravity assembles, expansion separates, structure only forms where gravity wins locally, pulling matter together faster than expansion can carry it apart. And here is the discovery that reframes everything. Several billion years ago, the expansion of the universe stopped slowing down and began to accelerate, driven by something astronomers call dark energy, whose nature remains one of the great open mysteries of physics, but whose effect is brutally simple. Space now stretches faster and faster every eon, and gravity's window for building new large structures is closing. The clusters that exist, like Abell 2029, are already bound, their gravity long since victorious, their internal futures secure. But the growth of new, larger structures, the gathering of clusters into even greater bound swarms, is being strangled by the acceleration. Matter that has not already fallen toward a structure is being carried away from it faster every year. And there will come a time, not infinitely far in the future, when nothing new of any great size will ever form again. Astronomers can state it plainly. Rich galaxy clusters are the largest things gravity will ever finish building in this universe. There is no next rung on the ladder. The hierarchy that ran for 13 billion years, small into large into enormous, is completing its final generation of structures now, in the cosmic era you happen to be alive in, and then the assembly line stops forever. Think about what that means for tonight's giant. A brightest cluster galaxy is the crown jewel of the largest kind of object the universe will ever complete. IC 1101 is not merely the largest galaxy yet found. It is very close to the largest kind of thing this universe is capable of making, sitting at the top of the last rung of the last ladder. At almost the last moment, such things can still be topped off. Galaxies meaningfully larger would need more meals delivered over more time in deeper valleys, and the universe is now removing meals from the table everywhere at an accelerating rate. The window in which an IC 1101 can be assembled is, in the generous bookkeeping of cosmology, closing as we speak. It should not exist, in the sense that the odds were staggering against any particular whisper in the fog compounding so perfectly, and nothing appreciably grander will ever exist in any future era, anywhere. When astronomers measure this galaxy, They are not just measuring a big object. They are measuring the practical upper limit of creation, the high watermark of what gravity, given the best starting position and all the time in the world, managed to accomplish before the tide turned. There is one more twist in this part of the story, and it is the kind of twist that keeps astronomers up at night in the best way. You might suppose that 100 trillion stars is simply the most matter ever gathered in one place. End of story. But the stars, magnificent as they are the minority of the giant. Everything we have described tonight, the swarm of the cluster, the smooth halo, the orderly orbits of stars through the enormous body, all of it moves too fast to be held together by the visible matter alone. The stars of IC 1101 and the galaxies of Abell 2029 and the hot X-ray atmosphere between them all swim inside a vastly larger reservoir of unseen mass, dark matter, whose gravity does most of the holding and whose nature nobody on Earth yet knows. The cluster, weighed by the motions of its galaxies and the pressure of its hot gas, comes out to something like a quadrillion times the mass of the Sun. 1,000 trillion suns worth of gravity, of which the shining stars are only a few percent. The true object at the center of Abell 2029, the real body of the king, is a mountain of invisible mass, many millions of light years across. And the 100 trillion stars we can see are the froth on its peak, the thin lit surface of something mostly hidden. In a very real sense, we have spent tonight describing the visible part of a creature whose full body no one has ever seen, only weighed. That is not a gap in the story. That is the truth of every galaxy, ours included, and the giant simply displays it at the grandest possible scale. The universe builds in the dark and lights only the tips of its work, so the giant stands at the ceiling of creation, mostly invisible, entirely silent, finished growing in every way that matters except one. The cluster still holds galaxies that have not yet completed their long fall. The valley is still collecting, which brings us, gently, to the future, because the future of IC 1101 is already visible in its present. The way the shape of a river's end is visible in its current. Astronomers know, with unusual confidence, what will become of this galaxy and of its swarm, and the forecast reaches so deep into time that it becomes, by its final pages, a forecast for every galaxy there is. It is the calmest possible kind of prophecy. Nothing in it is sudden, nothing in it can be averted, and nothing in it needs to be. It is simply what gravity and time do when they are left alone together forever, and it begins with the swarm finishing its oldest habit. The far future of the giant unfolds in 3 movements, each one longer than the last, each one quieter. The first movement is consolidation, and it is already far advanced. Over the coming tens of billions of years, dynamical friction will finish the work it began at the dawn of the cluster. One by one, the remaining galaxies of Abell 2029 will lose their speed to the swarm, sink down the valley, and be absorbed The brightest and heaviest first, the small and swift holding out longest. The giant will grow through every meal, its halo thickening with each new diaspora of digested stars, until, in the fullness of time, the distinction between the galaxy and the cluster simply completes its long dissolve. Where a swarm of 1,000 galaxies once wheeled, there will be one object, a single colossal fossil galaxy wrapped in cooling gas and dark matter, alone at the bottom of its valley. Astronomers already see older, smaller clusters in the universe well along this road, systems where one overwhelming central galaxy sits nearly alone, attended by a few faint survivors, and they call such systems fossil groups, the retirement communities of the galactic universe. Arbel 2029 is bound for exactly that condition. IC 1101 is not finished, being the largest galaxy ever found. It is going to become something for which we may not have a proper word yet. The totality of its entire cluster, every star that ever sank into the valley gathered at last into one final body. The king will outlast the kingdom by absorbing it completely, and while the giant consolidates, the universe around it will empty. This is the second movement, and it belongs to the acceleration we spoke of, the stretching of space that is already strangling the growth of new structure. The other clusters, the great swarms beyond Arbel 2029's gravitational grasp, are not merely far away. They are receding, faster every eon, and the acceleration means their recession will one day outrun light itself, carrying them permanently beyond any possible view. Over hundreds of billions of years, the sky around the consolidated giant will grow darker and darker, its distant companions winking out of reach one by one, until the fossil galaxy floats in a horizon of true emptiness, no other large structure visible in any direction forever. Every gravitationally bound island in the universe faces this same future, an eternity of perfect isolation, each island wrapped in a night that contains nothing else at all. It sounds like the loneliest forecast ever written, and from the outside perhaps it is, but remember the ember sky. From the inside, on the trillions of quiet worlds within the fossil giant, the loss will be imperceptible. The distant clusters were never visible to ordinary eyes anyway. The sky overhead will still hold its even salting of gold and crimson suns, night after night, age after age. Home does not feel like an island when home is 100 trillion stars deep, though there is one loss in that emptying future worth pausing over because it is a loss not of light, but of knowledge. And it makes our own moment in cosmic history stranger and more precious than it first appears. Think about what the astronomers of that far era will be able to discover, the watchers on worlds inside the fossil giant, 100 billion years from now, building their first telescopes under the ember sky. They will map their galaxy, star by patient star. They will find it vast and old, and everywhere the same. And then they will look beyond it out into the intergalactic night, and they will find nothing, no other galaxies, no faint smudges in Virgo, because every distant cluster will have been carried beyond the horizon of the visible long before. Even the deepest images their instruments can take will come back empty, and the great clue that unlocked everything for us, the stretching of light from receding galaxies, the evidence that space itself expands, will be gone from their sky entirely, with nothing left to measure a recession against. The gentle afterglow of the beginning, which our instruments read like a birth certificate of the cosmos, will have been stretched by then into undetectable faintness. Follow the logic of their evidence honestly, and those future astronomers, brilliant as they may be, will conclude that the universe consists of one enormous, ancient, island galaxy of red stars floating alone in an infinite static void, without beginning and without history. They will be wrong, and they will be wrong carefully, rigorously, using flawless observations of a sky that no longer keeps the old records. The truth of the expanding universe, of the hot beginning, of the 1,000 consumed galaxies inside their own home will be simply unrecoverable, everywhere, for everyone, forever after. Which means the era we are living in, you and every astronomer whose measurements fill tonight's story, is a privileged window that will actually close. We happen to exist while the evidence still shines, while the galaxies are still visible to one another, while the story of the beginning can still be read off the sky. Herschel's descendants, in the deepest future, will stand where Herschel stood in 1790, certain that their galaxy is the whole of everything, and this time there will be no Hubble to correct them, because the proof will have left the visible universe. The knowledge we gathered tonight is not merely rare, it is perishable. The universe is, right now, in the last age in which it can be fully known, and it told us so itself through the very telescopes it will one day quietly blind with distance. The third movement belongs to the stars themselves, and it is the longest and gentlest of all. No new stars are being made, so the giant's future is a matter of endowment, and its endowment is magnificent because the stars that remain are precisely the kinds that last. The sun-like stars will burn for billions of years more, then swell, brighten briefly, and settle into white dwarfs, compact embers that cool with almost absurd slowness, holding their warmth for spans that dwarf the current age of the universe. And the red dwarfs, the small patient stars that outnumber all others, have barely begun. A red dwarf sips its fuel so frugally that it can burn for trillions of years, hundreds of times the present age of the cosmos, and the giant holds tens of trillions of them. Run the clock forward 1 trillion years, 10 trillion, and the fossil galaxy is still shining, dimmer, redder, but shining, its sky of embers banked lower and lower, warmth without blaze, the longest afterglow there is. The largest galaxy ever found will also be among the last things in the universe still faintly glowing, a final hearth banked against a night that has no morning. There is no catastrophe anywhere in that future. just a slow settling past red, past crimson, past the last visible flicker into a dark that is by then universal and was never anything to fear. Now bring it home, because the reason this forecast can feel so calm is that it is also ours, and we should say so plainly. You are lying tonight inside a galaxy that is following, at its own scale and pace, the same road. The Milky Way and Andromeda, our two great local spirals, are falling toward each other right now, closing at about 70 miles every second, and in roughly 4 to 5 billion years they will meet. You already know, from everything tonight has taught you, exactly what that meeting will be. No collisions of stars, no danger to any planet, mists passing through mists, orbits bending, two beautiful disks dissolving over 1 billion years of slow embraces into a single rounded swarm of stars, a modest elliptical galaxy, our own family-sized version of the giant. Astronomers who cannot resist a good name sometimes call this future galaxy Milkomeda. Its combined black holes will pair and merge at its center, a small echo of the marriages of monsters that hollowed the heart of IC 1101. Its star nurseries will spend their last great reserves of gas in one final festival of starbirth. And then, over the following eons, the new galaxy will do what all finished ellipticals do. It will redden, it will quiet, its skies will become ember skies, even in every direction, gold and amber and deep red. No band of light, no galactic plane, just the same serene salting of ancient suns we imagined over that faraway planet earlier tonight. If the Earth's remote descendants, or whatever keeps watch from our neighborhood by then, look up on those nights, they will see, in miniature, the sky of the giant. The largest galaxy ever found is not an alien curiosity, it is a preview. It is every galaxy's old age arrived early, displayed at maximum size 1 billion light years away, where we can study our own deep future, the only way the universe ever allows, by looking at someone else's. And that, in the end, may be the giant's real gift, the thing it should be remembered for beyond all the record book numbers. It shows us that the universe's story does not end the way our instincts fear, in some final violence. It ends the way tonight ends, gradually, gently, with everything that was ever gathered still held close, cooling together at the bottom of a valley that gravity dug at the beginning of time. The most enormous object ever found by our species turns out to be a lesson in how to grow old, and the lesson is patience, and the lesson is calm, and the lesson is that even endings, at the grandest scale there is, look less like destruction and more like rest. Now, as we finally approach the end of tonight's journey, let us gather everything up, slowly, the way you would gather a long day before sleep. We began with a smudge, a soft, grey breath of light in a June sky in 1790, caught in a handmade mirror by a musician who had taught himself the heavens, logged with a number and set aside. And look at everything that was folded inside it. a body of stars 4 to 5.5 Milky Ways across, a veil of scattered suns reaching 2 million light-years from its heart, out into the borderland where a galaxy ends and the memory of eaten galaxies begins. 100 trillion stars, gold and amber and crimson, every one older than our world. A heart hollowed 14,000 light-years wide by the slow waltz of paired black holes, and at the center of the emptiness, a single monster of 40 billion suns or more, the final inheritor of every galactic center that ever sank into the valley. A cluster of 1,000 galaxies delivered to its table across 13 billion years, a crown that sits at the very ceiling of what this universe in all its remaining time will ever be able to build, and around all of it, invisible, the mountain of dark mass that holds the whole kingdom together. 1,000 trillion suns of gravity lit only at the summit. All of that in the smudge. All of that behind a filing number in the appendix of a catalogue. The universe does not advertise its greatest works. It leaves them folded in the dark, patient as everything else it makes, waiting to see whether anyone will look closely enough to unfold them. And someone did. That is the part of tonight worth keeping closest. Across 2 centuries, with mirrors and photographic plates and clenched patience, with debates in Washington and pulsating stars in Andromeda, with radio dishes and space telescopes and careful arguments about contour lines of glow, a species of small, short-lived creatures on a minor planet unfolded the whole thing. We measured the gulf, 1.15 billion light-years, and did not flinch. We weighed the king by light, by motion, and by heat, and the weights agreed. We found the scar in its heart and read the story of the scouring. We caught the thermostat in the act of holding the nurseries closed. We placed the giant on the ladder of hierarchical growth, on the last rung, at the closing of the window, and understood why nothing grander will ever follow it. None of this was given to us. Every fact you have heard tonight was earned, coaxed out of a smudge of light 1,000,000 times too faint for the eyes we were born with. Whatever else our species is, it is the kind of thing that can lie in the dark at the bottom of an ocean of air, on a spinning stone, and correctly deduce the biography of an object so large that its light outlives the species measuring it. The giant does not know it was found. It does not know it was named, or measured, or marveled at. The knowing all happened here. Every bit of the wonder in tonight's story is human. We are the part of this arrangement that notices, and that is not a small role. It may be the rarest thing in the whole story, because think of what the giant showed us once we finally saw it clearly. It showed us that the universe builds by patience, compounding tiny advantages over billions of years into the mightiest structures there are. It showed us that the greatest growth and the deepest quiet are the same story told at different hours, that the engine of a galaxy's rise becomes the keeper of its rest. It showed us that endings, at the very grandest scale, arrive not as violence but as settling, an ember sky, a banked hearth, a long and unafraid cooling. It showed us our own future, faithfully at full size, 1 billion light years early, so that when our own two spirals finally fold together into one quiet golden swarm, nothing about that night will be a stranger to us. It showed us that even the largest thing ever found is mostly invisible, mostly mystery, a lit froth on a dark mountain, and that this is true of every galaxy, and perhaps of every life. And it showed us that hidden inside the most intimidating numbers in astronomy, the trillions and the billions and the unbridgeable gulfs, there is something that feels, if you hold it gently enough, almost like reassurance. The universe is not in a hurry. It has never been in a hurry. It has all the time there is, and it spends that time the same way in every valley of its vastness, gathering, holding, and slowly, slowly growing calm. So let the giant do for you tonight what it has been doing for its own 100 trillion suns for 10 billion years. Let it hold everything so you can put everything down. Whatever this day left in your hands, the unfinished, the unresolved, the too much and the not enough, none of it is large. You have spent tonight among the true sizes of things, and beside the patient dark of Abel 2029, there is no worry in your life that deserves the word enormous. The light now arriving from the giant left home before anything on earth had eyes. It crossed the void through the whole age of fishes and forests and dinosaurs and ice, and it will keep arriving faithfully every single night of your life, whether you are watching or not. Nothing is required of you. The great slow machinery of the universe runs on without any effort from anyone, the valleys holding their kings, the embers keeping their warmth, the expansion carrying the far lights gently over the horizon. And all of it will still be exactly so when you wake. You are allowed to stop here. You are allowed to let sleep come and take the rest of this journey without you. And if you are still listening, still drifting somewhere just above sleep, then take one last look with me, the same look we started with. A dark field on Earth, on a clear night, facing the constellation Virgo. Nothing there to your eyes. A patch of ordinary darkness between the ordinary stars, but you know now what the darkness is holding. Behind that patch of sky, 1.15 billion light years down, the largest gathering of suns ever found by our kind is shining with the light of 100 trillion ancient stars, wrapped in the ghosts of 1,000 consumed galaxies, keeping its hollow heart and its sleeping monster at the bottom of the deepest valley in the nearby universe, at the top of the last ladder the cosmos will ever climb. It was there before your first night. It will be there after your last. It was there, already old, when the light of tonight left its shores, and your whole world since has been one long morning inside its single billion-year glance. Somewhere in its body, under an even sky of gold and crimson embers, the quietest evenings in the universe are happening right now, trillions of them at once, and they will go on happening, undisturbed, for longer than all the history there has ever been. The giant asks for nothing. The giant announces nothing. It simply continues the way the greatest things do, in silence, in patience, in the dark, immense beyond every measure, and calm beyond every need. Good night, then, from the little planet that noticed. Sleep the way the giant shines, slowly, steadily, without any hurry at all.